Oh, take your hand off the mouse. Stop scrolling. We're going to talk about the one-shot bit today. So I posted this riddle on Friday. We've been doing this recently, just popping a riddle up so we can have a discussion. And I had a pre-recorded video that I was going to do an addendum, kind of like I did last time. But there was so much discussion, and I think so many things that need addressed that I decided, well, let's just hit the live button and talk about it. So here is it again. So quick answer, and most of you had jumped out really quick. The quick answer was, I once was lost, but now I'm found. I was blind, but now I see. But I asked you, what is the error in this? And this is where things got kind of interesting. And I'm not going to pick on anybody. I'm not going to, go through exactly any of them, but let's just talk a few of them out. As many of you thought that found was going to chatter because you had the lost and you had the found, and that was going to make that chatter. And then many of you thought that blind would never be true because C was writing a 1 and that was going to block this. And this is it was by accident, but this is another good example of why we need to understand program scan to figure out the outcome. Now, first, just to nail down the fact that blind and C actually do something, I have added 2 rungs to this. So here is my program, and it's the exact same program. Now for those of you wondering, the flaw, actually, if we go back over, the flaw in this was I didn't have an address for the one shot. And I see this too often. People are like, well, if I'm not using anywhere else, why do I need an address? That was all we wanted to talk about. And it just spiraled into so many different things. But yeah, so what? I've added an address of once to this, and we're going to talk through it. Now, what I've also added is just so you can see, I have lost and blind latching output 0 and output 1. And while you'll never see it on the screen, when I toggle input or my I bit, you're going to see the yellow and the green light turn on. So right click, toggle, and they both come on. And we can see right here now that they were both on. So we know that they were on, whether we believe it or not. But let's talk through how this one shot works and how people get confused on this. So first, let me go ahead and just put this back as we had it. All right, so this instruction, and another thing that, and I'm not really trying to rail on you guys, but the ones that had the most bizarre answers to this use the terms normally open and normally closed. If you will soon get those out of your head and start using the go look for 1, go look for 0, you'd be amazed at how you can quickly come up with a very predictable outcome. But let's go through how it actually works. So this instruction is going to go look for a 1. And if we mouse over it, it has a 0. So right now it is false. And that is going to pass false conditions over to this one shot. Now, here's where we get confused sometimes on we think things either have to read something or they have to write something. Well, the one shot actually does both because it's going to read from its storage bit. It's going to write to its storage bit, and it's also going to pass conditions out the other side depending on it. So we had a false coming into this one shot. A false one shot always will write a 0 to its storage bit and pass false conditions out the other side. And that is going to write a 0 because remember, as we've been discussing the last months, false instructions do things. So a false output energized goes and writes a 0 to lost. Now, a little bit about this flow, because this is where people started getting confused, is you want to try to parallel and say that all this is happening at once. But it's not. We actually can only do one thing at a time. So it's going to start at rung 0. It's going to do the leftmost instruction. And then it's going to get to this branch. It's going to do this lower level first. And when it gets to this end of branch right here, it's going to go to the next branch. And it's going to get to this branch, and it's going to do this lower level. And this is going to go look for a 1. This is not a normally open instruction. It's going to go look for a 1 at lost. It has a 0, so it is false. And it's going to go to this end of branch, and it's going to come down here, and this is going to go look for a 1 at found. It has a 0, so it is also false. Now, I do not have a continuous path of trues from left to right because I have a true here at that point, but I do not have a true here and I do not have a true here. So found is also going to be false. All right. I'm sorry. I said this has a true. This has a false. I have a false here, a false here, a false here. So this found is false and it's going to go right as 0. Now I'm not going to toggle this bit yet. We're going to talk through this one right here as if we were toggling it. So imagine me right clicking and I'm going to toggle, which would put a 1 in this bit. That's going to go look for a 1. And then in this case, we're going to use our imagination and say this was a 1. So it would be true. A true one-shot goes and looks at its storage bit. If it sees a 0, and only if it sees a 0, will it pass true conditions out the other side. Now, it's got to remember that it already did. It's got to remember that it had a 0 that time, and that's what the storage bit's all about. You know, a lot of times we think, well, you only need this if you're going to use it somewhere else. Well, no, that's how it remembers what it did last time. So since it saw a 0, it's going to write a 1 just so it remembers next time that it doesn't need to do it again. And it's going to pass true conditions to lost. So that will go write a 1 to lost. And then we're going to get to this branch. And again, this is why the order was so important in this exercise. Is then it's going to go here. Then it's going to go here. And it's going to do the lower level here. This is going to go look for a 1 at lost. Now, a couple of you were really confused on this because we've been talking about program scan. Does this have a 1 or does it have a 0 at this moment? This has a 1 because this just wrote 1. Now, I know we went through the program scan and we talked about that the outputs were updated in the Slick 500s and the MicroLogics and everything at the end of the scan, but these are immediately written to. So when this instruction wrote a 1 to lost, and then this comes and looks for a 1, it will have 1, and this will be true. Now, just because this is true, it does not skip over this bottom part. It's still going to do a very repeatable process and go down here. It's going to go look for a 1 at found. And at this moment in time, found has a 0 in it. And then it's going to come here, get here, and it would have a continuous path of trues from left to right. And that's going to write a 1 to found. Now, in a very short amount of time, in fact, let's just pop over there and see. In a matter of 7 microseconds later, this is going to come back around. This will not have changed. This goes and looks for a 1 at I, and it'll have 1. I know it doesn't right now. We're just trying to slowly talk through this. And then it's going to get here, and it's going to do this lower one first, and that's going to look at the storage bit. So if a one-shot has a 1 in its storage bit, which it would have from the previous scan, it simply passes false conditions out the other side. And that's why we typically say this is true for one scan. Now, I've seen one program ever that it was legit and was actually one occurrence of 1 to the next occurrence, but it was a crazy program. But all right, we're going to be back here. This instruction is going to be false, and again, a false output energized does something. It's going to go write a 0 to lost. So that lost bit is only going to be true for one scan. And it's going to get here, it's going to come here, it's going to come here, and then this is going to go look for a 1 at lost. This just wrote a 0 to it, so this is going to be false. It's going to come here, and this is going to go here and look for a 1 at found, which the previous scan wrote a 1 to found, and it's going to be true, and that's going to continue to write a 1 to found. And this is going to be the seal in that we talk about. All right, now let's just watch this one time in here. We're going to come to rung 1 in a second, but let's just watch this one just so you can see. You'll never see this lost, but we know it was true for one scan because of rung 2, where I've added this latch here. So I'm going to right click at the I, toggle bit, and lost is not on, but we know at one time it was, and then we have an output on found. All right, let's talk about rung 1. because it operates a little bit differently. It's okay. This one is going to go look for a 1 at I, and we're doing real time here now. So it has a 0, so it's going to be false. Now, a lot of you really got confused because you're trying to use the go look, or you're trying to use normally open and normally closed and logic this out, and you can't do it. That's why I keep telling you guys this is okay. In the end, this is a go look for a 0. This is not a normally closed instruction, and it's going to go look for a 0 at C. It has one, so it is true. Now, I do not have a continuous path of truths from left to right, so blind is going to be false. Or the output energized for blind is going to be false. So it's going to write a 0 to blind. And it's going to come here, and it's going to come here, it's going to come here, and then here. And this is going to go look for a 1 at blind. It has a 0, so it is false. So it's going to go here, to here, to here. And this is going to go look for a 1 at C. We mouse over it. It has a 0, so it is false. So I don't have a continuous path of truth from left to right on this one either. And a false output energizer is going to go right a 0. Now, we're going to use our imagination just so we can do it slowly. We're going to imagine me right-clicking and toggling this bit, which is going to put a 1 in it. So this is going to go look for a 1 at I, and it'll have one. So this will become true. And this is where you guys got confused. I say you guys, it was a few of you, it was not everybody out there. Is this order of operation now becomes so important, because if we think that it does parallel or it's going to look at the C first, then this would be false. But at this very moment in time, nothing has written a 1 to C. It still has a 0. So it is still going to be true. And that is going to write a 1 to blind. It's going to go here, then it's come back here, it's going to go here, and this is going to look for a 1 at blind. And this just wrote a 1 to blind, so it is now true. Now, even though it's true, it's still going to get here, come over here, and then go to this one, and this is going to go look for a 1 at C. It has a 0, so we have a true and a false. But I do have a continuous path of truths then from left to right, and that's going to write a 1 to C. Now, 7 microseconds later, this comes around. I hasn't changed any. This is going to go look for a 1 at C, and then it's going to have, this is going to look for a 0 at C. Now it's going to have a 1, and it's going to be false. And again, false instructions do things. So false output energizer is going to write a 0 to blind. It's going to go here, and then here, and then here, and then here. And it's going to look for a 1 at blind, but it has a 0, so now it is false. And then it's going to go here, here. It's going to look for 1 at C. The previous one will have written 1, so it'll be true, and that's going to keep it going. So now I'll right-click, and I'll toggle it. And whether we believe it or not, for one scan, blind was definitely true. All right, let me catch up on the chat a little bit here, and we'll talk a little bit about a few other things. Hey, Michael, good to see you. Ivanka, yeah. Michael is somewhere way on up north, or he's getting ready to go north. Yeah. Where are you going to? Lottie? What's the temperature going to be there this week? Hey, Mary Bruce, I can see you live. Like, she's right over here in this room. But let's see, I like the nomenclature of these operators. You could always write the equivalent circlet that does the same thing with multiple rungs. Yeah, well, you know what? Honestly, I normally would, but I wanted to keep it kind of compact. I'm really struggling to write riddles on the board, so hopefully I'll get better. Another really good way to show this, put those variables into a trend to show it. Well, you know, honestly, you'll never see lost or blind. That's actually a really good one. Let's just go ahead and let's toggle this back. And whoops, sorry, this one. And we'll toggle this. And yeah, this is probably worth its own live stream, but just so we can see it, we'll trend lost. And then we will right click chart properties, and let's go to pins, and let's add our tag found. And I always forget to hit the add button. And we'll click OK, run. And we'll bring that out just a little bit, just so I can pop back to the right screen quickly. We're going to make this 10 seconds. And here's the trick with this is our sample rate is 10 milliseconds. So it's not going to ever actually capture that. So if I toggle that bit and I jump over here, oh, well, what did I do? Oops, I did the wrong one. Never mind. For a second there, I was like, wow, I was supposed to do blind. Let's try that one more time. Toggle you and toggle you guys back and properties. And put blind in. There, that'll work better. But yeah, because of that periodic, because of that 10 millisecond update rate, you're never going to see it. So yeah, that was actually going to be really shocked there. Let's see. Oh, Michael, a negative 3 degree. Hey, is that is that Celsius? Is that Fahrenheit there? So using counters, look bits always. Yeah, you're right. Counters could do it. You could lower the sample rate, but you're not going to ever get there. And actually, this is exercise we do with the technicians that come to our class. And yeah, you could go over here to your sample rate, and we could take it down to 1 millisecond. But you're still, this is in microseconds. So this is only going to be true for 7 microseconds. And that's why understanding program scan is so super important. Now there is a little bit of difference in how these two operate, and I was kind of waiting to see if somebody would actually say something. One other one before we do that, there was a lot of you said there was no way to reset our seal in here the way I had it written. Well, yeah, we actually can reset our seal in, and I'll show you how we can do that. Is if we wanted to make this fire again, all we need to do is write a 0 to found and see. And to show you that, I'm going to toggle these two off, and I'm just going to add a rung, and I'm just going to say, call this, I don't know, lost, and sometimes words, blind again. And I will create that. And then, a lot of you have been hammering me lately about latches and unlatches, how you should never see them in programs. But, I think y'all say that a lot of times because you're not sure how they work. But if I simply put unlatch found and unlatch C, that will make this ready to go again without any other interaction. So, and we have our lost and blind here, so we can see that they're going to fire again. And so we'll toggle that. Oops. Man, I did it again. All right, well, one of these days I'm gonna get the right stuff in here. And actually, wait. Oh, okay, now that, yeah, this one. Oh, all right, well, here, I was not prepared for that to happen. There you go. This is what happens during a live stream. But yeah, lost will not reset. Although I can. Yeah, I still can do this. I'm gonna reset instead of lost. Instead of found. All we got to do is reset once. Now, I would never think, I can't think of a single reason anybody'd ever do this. But just to show that these bits aren't magical, we'll toggle you, and we'll turn you back off, and you back off. And yeah, just so we can see that even this once, we can write a 0 to it, and lost will fire again. Toggle, and yeah, they both fired again. There is a little bit of difference in how these operate, though. Let me go and just delete that back out. And really, I didn't know we were going to end up this deep in the weeds of program scan, so I didn't go that far into it. But if we toggle off if we toggle off I, this is going to be ready to go again. Actually, this one is too, though. Somebody put in the comments that they would operate differently. Honestly, I'm not seeing that. Yeah, they look like they would be exactly the same. Well, let's just try it, make sure. So, oh yeah, yeah. So, in the end, they are going to operate identical. So, anyway, it was easier to hop onto a live stream and try to do it than try to add this onto the one I already had. But let's see, where are we at here on this? Let's see, lower sample. Tell Wilborne, do you like Allen Bradley or Schneider Electric? Allen Bradley quality fan. You know, I say they're both quality. If they weren't, then one would be out of business, and so they both have a place. And yeah, I mean, I believe, you know, and honestly, I mean, talking about that, I mean, here's why I firmly believe if you will really understand program scan and understand these basic instructions, I think you can go from one brand to another brand without any issues. Right now, I'm learning Siemens right now, and honestly, it's the same as Allen Bradley to me. In fact, I was debating on doing a Siemens programming series from the ground up, but I really think I'm going to do a series on how to understand Siemens TIE portal from an Allen Bradley perspective. Because really, there the biggest difference is understanding blocks, what they consider a block, and what Allen Bradley kind of considers a routine. That's the only major difference. So really, I mean, they're all here because they're all good. Let's see. I like using one shot cap. Absolutely. I mean, and, you know, the one shots are that's the main reason for them. And you know, they're the hardest to troubleshoot though, because you're looking for something that has happened in the past, not something that's currently happening. And that's one that we go through a lot with the people that come to our class because yeah, really, you kind of get lost as like, well, this isn't true, so it can't be the problem. But it's like, well, we know it had to happen though. So yeah, the one shot's really good for that. Let's see, unlatched latch can be super useful if used responsibly. The problem is a lot of people do not understand them and use the band-aid. Yeah, no, I'll absolutely agree. And you know, and honestly, I don't usually get into rules, but I do admit during, you know, when we're teaching people to program PLCs, if you go through any of our online lessons, we kind of start out with the go look for one, go look for zero, output, energize, and learn to do most things with them. And then we bring the latch, unlatch in, because you're right. I believe the latch and unlatch are used to cover up not understanding program scan. Now, I believe a lot of you use a lot of crazy rules to cover up not understanding program scan too. So I don't want to knock the latch unlatch really hard, but yeah. Let's see. I like Eaton, Dayton. Oh, well, yeah. I mean, yeah, they're all good. Yeah, I mean, yeah, all brands are good. Otherwise, like I said, they'd be out of business. Let's see. The biggest difference between any of these companies is understanding the core. You're right. I mean, and we call them quirks, call them features. It depends on, you know, your viewpoint. I've you know, I do believe I'm going to probably what I'm going to kind of focus on is trying to understand those differences so that we can naturally progress. Because, you know, I still, you know, as y'all are throwing all these languages out, I think yeah, well, yeah, the features, quirks, it's hard to tell what they're called. But, you know, I still firmly believe you find one brand and the most popular brand in your area and learn it and stick with it until you become, I won't say an expert, but until you have deep knowledge of how it works. And then you can go to another one. Because you know, and I knock schools pretty hard on this. I know you're trying to satisfy a huge workforce, and some of them have Siemens, some of them have Allen Bradley, some of them have Omron, Mitsubishi, and you're like, yeah, we spend 2 weeks on this, 2 weeks on that, 2 weeks on that. I'm like, okay, but did they get any deep knowledge of how a control system works? So I still believe you find one and you stick with it, and then you'll really easily be able to transfer to another one. All right, that's all I have for today. But I hope you're liking these programming riddles. If you are, hit that subscribe button. And if you have a particular riddle you think would be good, go ahead and throw it down in the comments. Have a great week.